if the air filtration is taken care of and maintained properly, they'll last indefinitely.
Oh, that's Rob from Kickback Garage. Hello Rob, how are you?
It's good. You're in the garage, mate. What are you working on at the moment?
This air ride Lambretta thing.
Is the hot rod stood still?
I've been doing a bit of work on that as well, switching it up a little bit, yeah.
I'm phoning you because I've been a little bit naughty. If you have seen my latest video, I have sent my cylinder to the UK, and I see that the plant that I've sent it to, they're not far away from where you live. So what I was going to ask you is, what are your plans this week?
So this is the cylinder from your Series 2?
The RT cylinder.
It's the electro plating, isn't it, that we're interested in?
It's the Nikasil. What I really want to know is how they find out the bore and stuff like that.
Can I see the scooter it's come out of?
I see it actually moving, because at the moment it hasn't got the engine in.
I have watched a video of you removing the cylinder, so yeah, I know the cylinder in question.
Cool, perfect.
Oh, nice hoodie you've got on, by the way.
Did you not notice that? It's very nice, thank you, sir, yes.
I look forward to reporting back to you on the progress of your cylinder. James Bond style secret mission.
Really looking forward to seeing how that turns out.
Great. Okay, I'll catch you soon.
Bye-bye.
Bye-bye. Back in Weston-super-Mare on a little industrial estate, and I'm visiting a company called Langcourt who specialise in cylinder plating. Let's go on inside and have a look around. Right, I'm just sat with Jeff here now in your lovely room in Langcourt, and we actually have Rob's cylinder in front of us.
We do.
Look at this, Rob is going to be well jealous.
Very first step was to stamp on it, or to mark it with a number, and you see the number on this particular cylinder is 08012503. This cylinder arrived on the 8th of January 2025, and it happened to be the third cylinder that arrived on that day. It allows us to track the cylinder through the system. Now that we got the number on it, we're not going to lose it, hopefully, and if the cylinder had come in with a piston or any studs and things like that, we would identify those with that same number, so that when the cylinder goes out, we know that the right parts are going out with it.
I know Rob is keen to know what you thought of this cylinder when it arrived, what kind of condition it was in.
It was in relatively clean condition, because on a Lambretta it's pretty well protected. Mm-hmm. So we didn't have an awful lot of work to do in cleanup, although it goes through the standard process, which certainly includes a bead blast, or a wet bead blast, which would normally clean up any oils and contamination on the outside of the cylinder principally. And then we can take a real good look and see what actually needs to be done. Sometimes after the cleanup, we can see work that's required that wasn't obvious before. Really, it's the outside of the cylinder, and if there's paint on there or anything loose, any oil, any carbon, particularly in the exhaust port, there's going to be a lot of carbon typically. We need to remove that before it goes into the plating process, because that will contaminate our solutions, and when we get contamination, that's bad. This is essentially stage one of the operation. After it's been logged in and it's been given that number, this is the first operation. So hopefully by this point all the carbon in particular has been taken out from the exhaust port, and it's just physically clean, so we can now deal with it as if it's a new part almost. The next step is it will go into an acid bath, and it's just simply immersed in the acid bath, and that will dissolve off the old Nicasil.
Okay.
Some of the older scooter cylinders are actually chrome plated, hard chrome plated, and that uses a slightly different process to remove that. After that, we can really have a good look inside the bore and see if there are any cracks that were hidden, that were just buried underneath the plating. A lot of times we'll find areas of porosity in the casting that weren't obvious when it was coated. So at that point we'll have a secondary inspection, and that will tell us whether we need to do any welding or any other repairs. We've got our little TIG welding station, and we've got a couple of ovens to preheat the parts.
So you can do a lot of the welding in-house then, can you?
Oh, we do everything in-house.
Oh, okay.
We don't subcontract anything out.
Okay.
That way we're in control. Just got a few cylinders in there. There was no welding required on this cylinder, and probably about 50% of the cylinders that we get need some sort of welding. So this is a cylinder that we needed to weld on this little bit of skirt. It was missing. So actually we didn't weld on the missing bit. We just built it all up from weld material, and now we're going to machine it, make it how we need to. This particular cylinder also had some detonation damage around the top edge. We've needed to weld that, and again we'll remachine that. We do have a question. Apparently this particular cylinder may prove to be scrap, and I don't know why. Oh, it's because we've also got a lot of weld on the exhaust bridge, and often on this particular model welding an exhaust bridge is not successful.
And what engine is this from then?
This is a Yamaha YZ125. Actually, you see there's a lot of different places in there that have needed to be welded. Perhaps we should talk a little bit about why there's a coating on the bore instead of, a long time ago, the entire cylinder would have been made out of cast iron.
Definitely something that I was going to ask you about, actually, because this is a cylinder kit that Rob has added. So I was interested to know, do all aluminium or alloy cylinders need a coating of some kind?
Yes and no. Typically they do. Aluminium cylinders that would go in most cars, for instance, would have a cast iron liner in the bore. So let's back up a little bit. Why do you want to not make the cylinder out of cast iron? Well, the first thing is it's probably 3 or 4 times as heavy. And if it's a competition engine, that's going to be important. The second thing is that cast iron doesn't transfer heat very well. Aluminium transfers heat far, far better. And then a couple of technical things about it. Cast iron is actually not very slippery. There's quite a lot of friction there. And on a coated bore, on a plated bore, there's less friction. And I suppose the other thing really that's relevant about cast iron is it's not very durable. They do tend to wear much more quickly than a Nicasil or a hard chrome plated bore. And if you go back a long time ago, that's why every now and then you'd send your cylinder out for a rebore, and you'd go in with an oversized piston, and that's really just because the bore was worn. That isn't an issue anymore with the plated bore. Plating thickness is typically about 0.1 of a millimetre. So on the diameter that would be 0.2 of a millimetre. I think this particular cylinder was 70 millimetre was the bore size. So we would normally expect the bore, after the old plating was removed, we'd expect it to be about 70.2 millimetre. 0.1 of a millimetre, which is the thickness of the plating, is about the thickness of a piece of paper. The next step is to make sure the bore is straight and round. It's a very quick honing operation. We're not looking to make it a particular size, we just want to make sure there's no low areas within the casting, or any mass distortion, which there could have been if the cylinder had ever been overheated. So we've got that little honing operation. At that point, we know that the bore is straight, and we know it's round, and we know it's an appropriate size for us. Cylinder we just looked at there, when we've welded it, we can use this operation to make the bore straight and round, but we then still got lots of weld inside some of the ports that would need to be removed, and we will do that manually. You can just take a look around this corner. to go into a series of pre-treatment solutions that conditions the bore so that the plating, when we start to do that part of the process, the plating will adhere properly. Aluminium is a very reactive metal, and it oxidizes very quickly in the atmosphere. So the chemicals that we use prior to plating removes any oxide layer, removes any oils and greases and things like that. And it prepares the bore surface in particular to accept that plating and to ensure that we get that good adhesion that's so critical. So if you imagine if you just had the cement in concrete without any rock in there, with no aggregate, it really wouldn't wear very well. It would be quite soft. The stones, the pebbles and the aggregate that's in there actually gives the concrete its wear resistance, and all that the cement does is it binds all of those little rocks together. Well, imagine that on a microscopic scale. The nickel takes the place of the cement, and the silicon carbide particles that are in there, which are very, very tiny, take the place of the aggregate that's in the concrete. We can play around with the hardness of the nickel, which is like changing the makeup of that cement. Yeah. But we've optimised that over the years, and we control that very carefully.
So, I like the cement reference because I've been doing a lot of building work, footings and dealing with those exactly. So that makes it, to me anyway, it makes it really clear. With the other people that are plating, are there sort of secrets in this field and things, and you've got your own like recipe for the plating and that kind of thing?
Yeah, for sure. Everybody, there are not so many companies in the world that do what we do, no. But everybody that does has developed their own little variation, and of course I'm sure everybody thinks that theirs is the best.
So far we've gone through the process of when a cylinder arrives and the clean-up processes. Then it goes into the plating room. That's a technical term, which I haven't filmed in there because that is a process which Jeff is said he's developed up for years and years and years. So, but I've just had a quick look in there myself, and it's very interesting. And the cylinders get plated in there and come back out again. And obviously the plating has got some kind of lifespan. The information that Rob's told me that this engine was built, I think, a few years ago, and it's done about 33,000 kilometres. Mm-hmm. So what's that, 20,000 miles-ish? Yeah. Is that the kind of life expectancy you would expect out of Nicasil plating? If
the filtration, the air filtration is taken care of and maintained properly, they'll last indefinitely, really. Usually it's the fact that you get dust in there, or grit, or water, or there's some sort of source of mechanical damage, and that's what causes the problem. Yeah, a lot of Lambretta riders do, ride with a carburettor with no filter on. That's including Rob. Yeah, that's the problem. And Rob, I did watch his video where he stripped the cylinder, from the engine, and he shows on his video there is some slight wearing, I think, around the ports mainly. That will be as a result of dirt getting in there. Yeah. And I'm not talking chunks of grit, I'm talking just dust that gets sucked in over a long period, and it will wear. Actually, more relevant than the wear on the bore would be the wear on the piston, because that's aluminium and not very durable, so you get grit in the space between the piston and the bore, and that piston will wear. Once the piston wears, now the clearance between the piston and the bore is greater, and the piston can actually start to rock back and forth. Instead of sliding nice and clean up and down the bore, it rocks. When it rocks, the piston rings will start to dig in, because you don't have that parallel side of the rings that's sliding nicely up the bore. So that will create some wear, typically right at the very top dead centre position, and usually at the front above the exhaust. It's not unusual to have hundreds of thousands of miles on a Nicasil type bore. I do need to say everybody knows this process as Nikasil. Nikasil is actually a trade name that belongs to a company in Germany. We never claim that our product is Nikasil. It's a nickel silicon carbide composite electroplate.
Thanks for clearing out.
Just wanted to make that clear, because everybody calls it Nikasil, just like everybody calls it a Hoover or a fridge. It's a generic name. We're very careful never to call our product that.
And once that is then plated, do you then do any more kind of honing or clean up?
So yeah, we'll apply that new nickel silicon carbide coating, and when we do that, we'll actually make the bore a little bit smaller than the required finish size. And now we've got a little bit of material that we need to remove by honing. And that does a couple of things. First, it gives us a very precise bore diameter and straightness. And it also gives us the correct surface finish, which is very important.
So after the cylinder's been plated, we're back out to do some more clean-up after the plating process.
You see we got very small build-ups on these port edges. Any sharp corners, the plating will tend to build up preferentially. Before we put this cylinder on our honing machines, which have got very carefully protected diamonds on there, we want to take off this little excess, and we'll do that just mechanically with hand tools. We'll just grind some of those edges, and then we come to the honing operation, which is on these machines here. This is very precise. So this is one of our tools. This was made in Germany. These are diamond strips that are on there, and the diamond is what does the cutting work. It's very important that each of these stones, each of the diamonds is very straight, because that's what gives us the geometry on the bore. And we got a variety of machines. These are all German machines. They were very well built and they last forever. They cost a fortune. To buy one of these machines now, if you can buy one, it's probably £1 million. Tools. I mean, we got lots and lots of these hone heads. Each one is for a very small size range, and we've got different grades of diamonds. Oh, there's no diamonds in that one at all. So this is a very rough diamond. We've also got, actually that's a rough one as well. This is a finished diamond, and you probably can't tell, but the diamonds in here are much, much smaller than they are in the roughing set.
And so you're just swapping them out, right? I'll start with rough and then
we'll start with rough, and yeah, that's exactly what happened. Some of these machines have got twin spindles, so we're able, if we wanted to, we could drop on this spindle and finish on that spindle. We don't always do that. We work a little bit differently. But,
and do they put a certain amount of pressure on?
Yeah, we need to expand the diamonds at a controlled rate, and that's done by hydraulic pressure on these particular machines. What most people would see is that crosshatch pattern that's achieved during the honing process. But that honing profile, if you like, is a series of peaks and troughs. And we have established what we believe to be an ideal surface profile, and our normal honing program produces that finish. It is possible for us to adjust that a little bit if a particular customer wants us to. We wouldn't normally do that on a one-off basis, because we are confident that our normal specification works very well. But from an OEM point of view, sometimes a customer will have a particular requirement.
And that final thickness of coating, are you confident of the thickness of that from measurement, or do you have some kind of fancy, thing that can test the thickness?
It's a physical measurement. If we do have a piston, and sometimes the customer will send us a piston and give us his required specification in terms of clearance, we'll measure the piston and then we'll make a note of what the intended finish size needs to be, and that's what the customer should get. Often the customer won't know what he wants really, so we would then go to standard sizes so far as we understand them. And if we've got any uncertainty about that or any question about what a particular make and model of cylinder will need, and that could, the clearance could depend not just on the make and model of cylinder, but also the make and model of piston that's going to go in there, because some pistons expand more than others. We normally have enough experience of all of those factors to decide ourselves, or to make a recommendation to the customer what clearance it should be. We had a final inspection, so all of these ones are finished, waiting to be packed and shipped out to our customers. They come in all sorts of shapes and sizes. When they go out, they're packed in this foam and all the parts. So you remember when we gave the cylinder its serial number, the same number goes on the piston, and any studs and things like that would go in a sandwich bag. And
there you go, Rob, safe and sound. Rob, your cylinder is on its way back to you, and I just want to give a massive thanks to Jeff giving me his time and showing me this amazing factory workshop. I'm not sure what you call it. What an amazing place, and it's been a huge learning process for me as well, so really interesting.
Well, I'm glad it's been some benefit to you, and I hope your viewers appreciate the information.
Cheers everyone.